Partial differentiation. Introduction to partial differentiation. Partial differentiation is a mathematical concept used to calculate the rate of change of function with respect to the specific variable. It allows us to analyze how a function changes when only one variable is varied while keeping all over other variables constant. Partial differentiation is an essential tool in multivariable calculus and plays a significant role in various scientific and engineering fields. Classification of differential equation. Partial differentiation equation. There are two types of partial differentiation. First one is first order and higher order. First order partial differentiation involves finding the partial derivative of a function with respect to one variable at a time while treating the other variable as constant. Higher order partial differentiation involves taking the partial derivative of function multiple times with respect to differential variables. Example of partial differentiation. Example 1. Consider a function f of x y is equal to x raised to 2 plus x square plus 3xy minus 2y square. To find the partial derivative of f with respect to x, we treat y as a constant and differentiate each term with respect to x. Example 2. Let's find the second order partial derivative of f of x y is equal to e raised to x, that is exponential sin of y. First we need to find the first order partial derivative with respect to x and y. Then we differentiate these partial derivatives with respect to x and y again. Analytical methods for partial differentiation. Analytical methods involves using algebraic techniques to find partial derivatives. For function with unknown formulas, we use basic rules for differentiation such as power rule, product rule, and chain rule. These methods provide exact solution are particularly useful for similar functions. Numerical methods for partial differentiation. Numerical methods are used when analytical methods are not feasible or practical. Finite different methods approximate the partial derivative by evaluating the function at different points and using the difference in function values. Numerical methods are valuable when dealing with complex functions or when analytic solutions are not readily available. Numerical methods. Finite difference. Finite difference method involve discretizing the domain and approximating derivatives using finite differences. Forward, backward, and central differences formulas are commonly used to appropriate partial derivatives. The accuracy of finite differences method are defined on the step size and the order of difference formula. Numerical methods. Finite element. Finite elements method discretizes the domain into smaller element and approximate the function within each element using piecewise polynomial interpolation. Partial derivatives are then approximated by differentiating the interpolating polynomial within each element. Finite element methods are widely used in engineering and physical simulations. Boundary conditions in partial differentiation. Boundary conditions are constraints imposed on a partial differential equation to determine a unique solution. They define the behavior of the solution at the boundaries of the problem domain. Examples of boundary conditions including specific the values of solutions for its derivatives at concerned points. Initial conditions in partial differentiation. Initial conditions are the values of the solution and its derivatives at the specific point in the problem domain. They are used to find a unique solution to partial differential equation when combined with boundary conditions. Initial conditions represent the starting point of a dynamic process described by partial differential equation. Applications of partial differentiation. Partial differentiation is extensively used in physics to describe physical phenomena involving multiple variables such as heat transfer, fluid dynamics, and electromagnetic fields. It also vital in engineering disciplines like structural analysis, control system, and signal processing. In economics, partial differentiation is employed to analyze the product functions, utility functions, and optimization programs. Challenges in partial differentiation. Partial differentiation can become a challenging when dealing with higher order derivatives and complex partial differential equations. Finding appropriate boundaries and essential conditions can be difficult, especially when dealing with real world problems. Symbolic manipulation of partial derivatives can be complicated, intensive, and time consuming. Software and tools for partial differentiation is a MATLAB is a popular MATLAB is a popular software for numerical and symbolic computations, including partial differentiation. Python libraries such as NumPy and SymPy provide powerful tools for symbolic math and numerical computations. Mathematica is a comprehensive software package widely used for advanced mathematical computations, including partial differentiation. Let us come to the conclusion. Partial differentiation is a fundamental concept in mathematics with numerous applications in various fields. Boundary and initial conditions play a crucial role in determining the unique solution to partial differentiation equation. With the help of software and tools, the challenges associated the partial differentiation can be overcome, enabling analysis of complex systems. Thank you for watching. Please like, share.